Somewhere in the southern sky, 4 different telescopes had already taken a picture of the same planet, and for 11 years nobody realized it was there. This is not a story about building a bigger telescope or inventing new technology. It is a story about going back through old photographs and finally noticing what had been hiding in plain sight the entire time. Have you ever tried to spot a firefly sitting right next to a spotlight? That is roughly the challenge of photographing a planet directly. A star can outshine the planets orbiting it by a factor of 1,000,000 or more, so the planet's faint light simply drowns in the glare. Out of more than 5,000 confirmed exoplanets, fewer than 100 have ever actually been photographed this way, as an actual dot of light rather than inferred indirectly from a shadow or a wobble. So when astronomers do manage to catch one on camera, it becomes an instant celebrity. The first exoplanets ever directly imaged were announced back in 2008, around a star called HR 8799, followed soon after by a planet orbiting a young, bright star called Beta Pictoris. Since then, Beta Pictoris has become one of the most photographed stars in the sky, revisited again and again by nearly every major telescope on Earth and in orbit. Why this one star in particular? Beta Pictoris is only about 23 million years old. For comparison, our own sun is roughly 4,600 million years old, so this star is essentially a newborn. It is still surrounded by a huge, messy disk of dust and rock left over from its formation, the same kind of raw material that planets are built from. Watching a system this young is like getting to watch planet formation itself, frozen at an early, chaotic stage. Astronomers already knew of 2 planets circling Beta Pictoris. The inner one, called Beta Pictoris b, is a gas giant several times heavier than Jupiter, found back in 2008. A second planet, Beta Pictoris c, tucked in even closer to the star, was confirmed in 2019. Both of those planets sit inside a debris disk of dust and rubble, spanning roughly 30 to 200 times the distance between the Sun and Earth. We see that disk edge on from our point of view, like looking at the rim of a plate rather than down into it. Here is a question worth sitting with for a second. If astronomers have been staring at this exact star system for decades, with some of the most powerful telescopes ever built, how many other planets could still be hiding there, unnoticed? That question turns out to matter a lot, because direct imaging has a messy history. Have you ever wondered how many announced exoplanet discoveries later quietly turned out to be false alarms? More than you might expect. Several claimed directly imaged companions have had to be retracted over the years, once astronomers gathered enough follow-up observations to realize the planet was not moving the way a planet should. In some cases, it was simply a background star, sitting billions of times farther away, that happened to align almost perfectly with the target star for a few years of observations. So how do astronomers actually tell the difference between a real planet and an imposter? The trick is called common proper motion, and the logic behind it is surprisingly intuitive. Every star in the sky is drifting slowly across the heavens, carried along by its own motion through the galaxy. A planet that is gravitationally bound to a star drifts along with it, locked together, the same way a dog on a leash moves with its owner even as both of them walk forward. A background star or galaxy, on the other hand, is not attached to anything. It just happens to sit along the same line of sight for now. Over years, it will appear to drift away in its own separate direction, or stay eerily still while the foreground star moves on without it. Confirming that a faint dot next to a star is truly a planet, and not a background imposter, means photographing that same dot again and again, sometimes across a full decade. You have to check whether it keeps pace with its star or gets left behind. That is exactly the test that turned an 11-year-old mystery dot next to Beta Pictoris into a confirmed third planet. Have you ever wondered exactly what it takes to prove that a faint dot of light next to a star is a real planet and not just a trick of light? In December 2025, a team using an instrument called ERIS on the Very Large Telescope in Chile photographed a faint point of light sitting close to Beta Pictoris. It was not the first time that point of light had been captured on camera. It was just the first time anyone recognized what it was. Once the team spotted that faint dot in the new 2025 image, they did something that sounds almost old-fashioned for cutting-edge science. They went digging through the archives. They pulled up every earlier observation of Beta Pictoris taken by the James Webb Space Telescope and by another VLT instrument called Sphere, going all the way back to December 2014. And there it was, the same faint dot, sitting quietly in 5 older images that nobody had flagged as anything unusual. Why had it been missed for so long? Because for most of that decade, the mystery object was either too close to the blinding light of its own star to stand out, or it was hiding directly behind Beta Pictoris b, the brighter planet already known in the system. That known planet is up to 100 times brighter than the hidden one at some wavelengths. In the oldest image, from 2014, the 2 planets appeared almost exactly on top of each other from Earth's point of view. Researchers only managed to pull the fainter object out of that old data after digitally subtracting the brighter planet from the picture first, like erasing a bright light, so you can finally see what was standing in its shadow. So here is exactly what the data showed. Tracking that dot of light across all 6 observations, spanning an 11-year baseline, its position moved together with Beta Pictoris and along a curved orbital path, not the straight, predictable drift you would expect from a background star. The deviation from a stationary background object worked out to more than 24 standard deviations, a level of statistical certainty that leaves essentially zero room for coincidence. This confirmed dot became Beta Pictoris d, the 3rd known planet in the system. The numbers that came out of the analysis are striking. Beta Pictoris d has roughly 4 times the mass of Jupiter, with an estimated surface temperature around 600 degrees Kelvin, about 327 degrees Celsius, noticeably cooler than its 2 inner sibling planets. It orbits at a distance of about 26 times the distance between the Sun and Earth, farther out than both Beta Pictoris b and c, completing 1 full lap around its star roughly every 91 years. Its orbit sits in almost exactly the same plane as the other 2 planets, which lines up neatly with a puzzle astronomers had been chewing on for years. Something had to be shaping the inner edge of that huge debris disk, and this newly confirmed planet fits the role convincingly. There is also a chemical clue. Beta Pictoris d's brightness across different infrared filters points to strong carbon dioxide absorption in its atmosphere, suggesting a higher concentration of heavier elements than free-floating, planet-sized objects that drift through space with no star to orbit at all. Its colors closely match those of another young exoplanet called 51 Eridani b, reinforcing that this is a genuine planet that formed inside a disk of material, not some isolated object that wandered in from elsewhere. And this discovery was not made in isolation. A separate, independent team using spectroscopy from the James Webb Space Telescope detected the very same planet on its own, arriving at similar estimates for its mass and temperature at almost exactly the same time, which adds even more confidence to the result. Beta Pictoris now becomes only the 2nd directly imaged planetary system, after HR 8799, confirmed to host 3 or more planets. And if a planet this substantial could hide in plain sight for 11 years around one of the single most photographed stars in the entire sky, it raises an obvious question about every other fully mapped planetary system out there. What else is still sitting there, waiting for someone to look back through the archives one more time? The research behind this discovery was published on July 15, 2026 in the Astrophysical journal Letters, led by astronomers Ben Sutlieff from the University of Edinburgh and Marcus Bonse from the European Southern Observatory, together with a team of more than 90 collaborators.